I am Cree and Soto on my grandmother's side through my father, and English. And then on my mother's side, I'm predominantly Ukrainian through that branch. I started studying Cree um, in 2015, 2016. My grandmother suppressed it. She actually told all our family that we were French and we were originally from France, and we have zero French lineage, with the exception of my anglicized surname, Corbett, which is anglicized from the French corbeau, for raven, which also happens to be my English heraldry symbol, which is the raven, uh, and ironically fits rather well with my indigenous practices as well. So I will be presenting my topic today. I'm hoping uh, talking about I titled it Unveiling Indigenous Wisdom in Computer Software, Hardware, and Theory because Indigenous approaches to knowledge modeling, um, we don't believe in, I guess, technically speaking, we don't believe in invention. All the knowledge in the universe is there to be found. So we are simply uncovering knowledge, revealing it. So, for example, Sir Isaac Newton didn't discover or invent. He didn't invent gravity. He discovered it, that it exists, right? So all of the knowledge that we have in the universe that is knowable at the human level is only ever revealed. It already exists. So we're just going through the motions of discovering it. And so when I look at computing, what are the fundamental basic principles of computing, whether it's software or hardware or just understanding computational methods, uh, what indigenous wisdom is already innately there. It's already built into it. And if we do it that way, we can, to some extent, heal and fix some of the issues that colonialism has introduced through computation, our hardware, our software, the way we use computers in our everyday lives. And so that's what I'm going to be talking about today. I've broken it roughly into two components. One is hopefully a very brief background in decolonial computing, and some of the history in what I consider to be Western and colonial within computing, and then talk about the work that I currently do in addressing some of those challenges. So in Western and colonial histories, we typically there's a number of different problems that were introduced through colonial measures, and that seem to perpetuate. The number one being language. A majority of our programming these days is done in English. There are several languages that do use other, non-English languages, but for the most part, if you're going to learn how to program, programmers typically do it in English, even if English is not their first language. Um, there's also a tendency for cultural appropriation within the machine, within the mechanics that we use, our hardware, our software. We borrow from everyday life, and this is just a natural part of being human, and we do it every day, and sometimes we don't even know we're doing it. And we borrow from cultures and practices, even ceremony to some extent. I have got examples for some of these. There's algorithmic bias and discrimination, and obviously the environmental impact of technology. So looking at it from an indigenous worldview, if you want to balance our technology use, you have to do it in a way that is sustainable and environmentally friendly, and doesn't encroach on the environment as much as it currently does. So starting with language, just some examples, historically speaking, for those of you who might be old enough to have hard drives that were based on a master-slave arrangement. This typically referred to, I especially found it in hard drive, where you could serial chain hard drives together, but there was one master drive, and then you would connect that drive to slave hard drives. And they were, chained together in a sequence like that. And we refer to those as master and slave. Now, just based on the language that we use to refer to these types of relationships within our hardware is problematic, especially in today's environment, I guess, where sensitivities to cultural and racial histories are kind of at the forefront of what we do. Some of these terminologies don't exist. I can't remember the last time I heard of the master-slave arrangement within computing, for the most part, because they've been replaced with other terminologies. And even the use of subordinate, so the main and subordinate alternatives, subordinate still has that implication of a hierarchy that is problematic, especially if you're looking at it from an indigenous or a cultural perspective. Language also affects hardware. So some of the language that we've used over time in English for programming, or if you're used to command terminal line commands, we have words like terminate, erase, delete, kill, purge, destroy, wipe, overwrite, and expunge. And there's probably hundreds of commands that are, these are all the ones that seem to be mostly related to commands and file types, right? So I had written or created an artwork probably 10 years ago of purge, and it was purge, and I had a text document. So it said indigenous culture.txt, and then so yeah, as a command line, it said purge indigenous culture.txt, and it was a comment on this idea of language within our computing system and what they mean if you actually read out some of the terminologies that we use. Again, a lot of these are being replaced with a better language, I guess, that's a little bit more inclusive. But there's a long history of violent and forceful actions within our computing technology as far as commands go. From an English perspective, we don't, we're kind of insensitive. What do you want to do? And I want to erase this file. I want to get rid of it and replace it with something else, or, clean the drive in such a way that it can take new files. And it's something that I don't know if we'll ever get rid of, but there's definitely other ways we can approach that. Languages in practice, again, we tend to gravitate towards historical practices of, so for example, whitelist and blacklist. When you have something that you want to have a list of items, you'll usually see this in proxy servers or files that you're allowed to run and files that you're not allowed to run. They're whitelisted or blacklisted, but where do those, where did white and black come from? There's a lot of people that associate this to racial bias and racial discrimination into what is allowed and what is not allowed, right? So why is it white and why is it black? And it's a sensitive topic, and we continue to use these terminologies without really defining their histories or redefining what could be a whitelist, what can be a blacklist, and how do we refer to those lists of allowed and denied entities. And the same goes with master password. This is slowly losing traction, I think. The word, again, master, similar to that master slave example I talked about, where we have one single dominant password that we can use to recover, whatever we need in our system. We used to refer to it as master password, but it implies this power relationship and something that continues, through our computer use these days. Which brings me to cultural appropriation and misuse of indigenous knowledges. This was actually quite intriguing. This is from Lisa Nakamura's article, where she looked at the history of Fairchild Semiconductor. They had opened up a circuitry semiconductor factory in relationship with the Navajo reservation back in the 60s and 70s. And they hired, I believe they had to hire at least 50% of their workforce had to come from the Navajo Nation. So this was a way of improving the lives of the indigenous people of that area, and a collaboration between, what would be white capitalism and computing, and the indigenous people that occupy that space. And in their documentation that they presented, so they had this commemorative brochure. They, in a very veiled, read between the lines kind of orientation, represented their circuitry design as if it was, matched to Navajo tapestry and weaving, and that it kind of insinuated that the Navajo women in particular are responsible for weaving, were particularly well suited to semiconductor design because they already understood the way these orientations worked. And so this is just a visual example of an actual semiconductor from their pamphlet, and a Navajo rug taken from a gallery, that just shows how similar some of those traces can be between the semiconductor design and the actual weaving. And so the company was misusing indigenous knowledge as a way to, um, you know, I guess, solidify that they were doing good work with the indigenous people. This was a collaborative approach because these knowledges were fluid and can, travel from one to the other without understanding the greater implications of, what the weaving means and what those particular pieces of geometries represent to those people. Um, and this leads to some algorithmic bias and discrimination. There was a really great, I guess, Twitter war where somebody had taken a pixelated version of Obama, ran it through a machine learning process, and it created a Caucasian male as the output. And I just wanted to, test kind of these theories. So if you were, I went to DALL-E and I just typed in, give me a portrait of the average North American person. And these were the first 8 results that I got. I recognize that there's no females in that list or in these images. I was expecting actually a lot more white male, because it all comes down to how you define what average means. How does the system determine what average means? In terms of average what? Average height, age, average racial profile, or cultural makeup. Where do they come from? Who are they? And this would need more research, but it is something that you can identify in these AI systems that are coming out these days, in testing some of just the generic sampling. And this is this is something that that it returned for me. So I was intrigued, to say the least. And it definitely, I think, shows or is somewhat evident of algorithmic bias within the actual, model that they're using. Also note that there is a fairly good representation, I think, of cultures and racial makeups within these images, and which is interesting because if you understand average as maybe being specific to the American census, for example, there's 330 plus million people. The average person is male, the average person is white, and the average person is in their mid 40s or 50s, right? So if you interpret average in that perspective, I would expect to see that, and I see a couple representations here, but not a lot. But companies like OpenAI and other AI companies are already aware of how insensitive some of these are. So they make sure that there's a very diverse range of output. So if you type in average this, like average person, they're going to try and give you a very wide range. So they're going to be culturally sensitive to those, which is, I think going the opposite direction. They're introducing a range where that range isn't specified. So it's just an interesting way of looking at how computers are adjusting to cultural sensitivities, and it doesn't matter really what part of the world or what culture you belong to. They're trying to address and provide a universal output, and I think that has problems. And they're obviously, I mean, this is still a very early development, but I'm hoping that these trajectories change down the road. Which brings me to, I just wanted to make a comment about these opportunities for making computers agnostic or neutral. There is a huge push in the industry to look at, opening up computing so that there is no culturally relevant, where it's UI design, for example, is tried to be made intuitive. Removing language. You notice this at for me anyway, if I shop at Superstore, they've tried to reduce their UI and their self-serve checkout machines by removing all the language. So they have icons that are supposedly universal. But the first time I used it, it probably took me, 4 times or 5 times longer than it does today because it took me time to understand what those symbols mean. But anybody can use them once they understand that language, but you're still introducing language, right? We're using different symbols to represent the exact same things as language does. And so really, are you getting rid of the problem by just removing the English language? And why would there be a problem with having English and a graphic, or having a better hold or understanding of what those graphics are to different people? So the problem here is that whether you try to be agnostic or you try to be neutral, it's still shaped by the values of the people that make that technology. And so maybe if we move to a model that is more culturally inclusive and intentfully introduce cultural into the computing infrastructure, and then using culture to inform those, then we would be making the computing infrastructure a little bit more viable, I think, as a device to a wider range of people. You are, I think, in doing this, though, also going to alienate people that, are familiar with using computers in one way, and you introduce culturally specific language or culturally specific practices into computing practice, that's going to, alienate people. But those might be the people that we are not interested in focusing on. If it's there to support language, if it's there to support culture, and if it's there to support the people of a given community, does it do that? And that's where cultural computing can become quite effective. At the heart of all this is decolonial computing, which is really undoing or actively attempting to change, and challenge and dismantle these structures. All of the ones that I pointed out. So the language it's a natural barrier. The biases that show up in our algorithms that are a part of the system, and the power relationship between components, between interfaces, all of these are always relevant, and they're always a part of the system. So how do we look at making changes so that they are either not as impactful, or that the colonial underpinnings of those are reduced or removed? So for example, time is one of the great big things that I recognize, because in an English or a Western, Eurocentral model where capitalism is kind of key, time is money. There's a formula for representing time as it's directly equivalent to money. But if you look at indigenous models of time, time is about experience, and time is an ever-present thing. And how we refer to our past, our present, and our future is actually in a reverse model. You'll often hear indigenous people talk about the future, and like I mentioned at the beginning, all the knowledge in the universe is there to be uncovered. That we can. So the future is already knowable, right? All the knowledge in the universe is already knowable, and therefore there is technically no future. What we're doing is passing through a present moment of uncovering that knowledge, and then we're using it to reinterpret what does it mean for the past. And so, for an example of this is, I grew up self-taught in terms of computers and programming. When I was 25 and started my work at UPS, I thought to myself at that time, hey, all of these years I spent teaching myself how to play with computers and how to program and stuff has led me to this particular point in time. And this is what it was meant to do, right? That past experience was meant to be an explanation of where I'm at in this present. Now, skip ahead another 25 years, and here I am at Simon Fraser looking at these models of time and experience, and I look back to, the exact same experiences of learning how to program and revealing that, knowledge about how to manipulate a computer into doing what I want it to do. And it has I have a completely different understanding of what that process is, based on all of the experiences I've had since I was 25 until now. So as we reveal new knowledge and as we gain a better understanding of that, we reinterpret our past and we have a better understanding of what those represented in our past. Um, Really quickly touching on ethno-computing. So there is a movement in, I guess, academia, where we refer to ethno-computing. There are subtopics, and it's actually umbrellaed by a concept of ethnosciences. So ethno-computing includes ethnomathematics and ethno programming, I think is also in there. And what these mean are looking at computing from perspectives that are not necessarily universal. Things that we take for granted, like numbers, right? We use Hindu or Arabic numbers as symbols to represent one, to represent zero, to represent 10. But if you go to different cultures, they have different ways of counting. They have numbers that exist and don't exist. They have ways of representing those numbers. They have different symbols. And, in a Cree perspective, we have numbers 1 through 10. However, if you literally translate the number for 9, technically speaking, there is no symbol that means 9. We only have something that means almost 10. So abstractly, we have a number for 9, but specifically do not have a number for 9. And this changes as well for things like locating. So geography, in a Western culture, we look at if you were given a sheet of paper and you were told to write the 4 directions on there, you would write north at the top, south at the bottom, and the east and west on the right and left sides, respectively. And as we'll find, I'll show you in an example I have coming up, that's not always true, right? In different cultures, our reference to location and geography is dependent upon how we situate ourselves within that given environment. I've been questioning this one a lot. So indigenization is just the process of promoting cultural beliefs into Western context. So, and it is, I think, a response to colonization and colonial underpinnings of almost everything that we have. We tend to have this reaction of indigenizing something. So where we might have a process that is very rigid, very linear, we might introduce or indigenize that in some context to make it less so. And that's usually as a result of the colonial history that gets attached to certain processes. But and that's why I say that indigenization can only exist because of colonialism. If you were to undo computer development and undo colonialism, if we go back in time and make it so in such a way that colonialism never existed, it didn't become a thing, and we were still able to create computing, create histories of computing, and the knowledge that goes behind computing, I believe that the current imbalances that we experience in terms of the power and the resource exploitation wouldn't be there. And our computing experience would be far more inclusive and culturally collaborative. And you wouldn't have these challenges of representing single language, using English only for programming, or Englishly dominated, right? We would have ways of interacting with computers that we own cultural situation in those engagements. And so I'm stepping away from using indigenization because really, theoretically speaking, when you look at computing, and I'll get to examples of these, if you take away all the computers, if you take away numbers, if you take away these things, you will have a better understanding of what computers actually do at their essence, and they are inherently indigenous. I think this is one of the last topics for this section. So indigenization is just an offshoot of that. It was a word I created about bringing together Western knowledge. It's very online or on par with two-eyed seeing, which is a Mi'kmaq tradition of using the knowledge and understandings from your Western perspective and the knowledge and understandings from your Indigenous perspective, and allowing those to coexist in a braided, I use the word braided, where you're not allowing one or the other to take over from each other. You're allowing them to coexist at the same time, and so although you might be privileging cultural practices, you're doing it in such a way that you're not undoing any part of the system that's already there and is compatible with an Indigenous perspective. And so that braiding kind of looks like this. Um, and I introduced this with the future, present, past. So if you think of Indigenous time in this context, we get this transformation and hybridization in indigenization, sorry, of our relationship to technology, how we relate to that technology as technology advances. So as technology advanced from our physical mechanical technologies into our computer space that's digital, and now as we go into the future with our virtual technologies, those have a direct relationship to these timelines and to how we as myself as an Indigenous person interacts with those technologies. This would be a more modernized framework, I guess, of how you would look at Indigenous computing. So I use my Cree worldview as its source, and I look at hardware and the software and the intersection of those two in order to understand or present a theoretical framework that is rooted in Indigenous understandings. And again, it just goes through that multi-layered and braided diagram that I had shown about how we relate to these technologies. And because Cree is so rooted in relationships, understanding the relationships between one thing and another thing is critical. And our relationship to the land, our relationship with other people, our relationship with our tools, our relationships with our computers, our relationships with our employer and our employment and our hobbies, right? All of these things are related. If we understand those relationships, we can present or create better computational frameworks. And Cree, the word Cree, nehiyaw, means or comes from the word for four and body or spirit, right? So we have four bodies or four spirits, and those being spiritual, emotional, mental, and physical. And those four components have to exist in everything we do. So if you think of a computing framework as being spiritual, emotional, mental, and physical, most of us wouldn't, we would see spiritual, emotional as lesser parts of that system. And in an Indigenous framework, those have to be on par. They have to be equal to, right? So the amount of spiritual, emotional engagement with a technology should also equate to the amount of mental and physical engagement with that same technology. And this is just another way of explaining it. You'll see here, this is where I used to think of it as deconstructing technology, indigenizing it, and then reconstructing it. Really, what I'm doing is deconstructing technology, finding out how to express that in a cultural, language, using the language and understanding of my culture, and then I reconstruct it. And so how it physically comes back together with a understanding and a cultural understanding at the base is really what is key in this. And these other points I've already kind of mentioned, but I also use real world analogy and experience in order to identify processes within the system that can be explained from a cultural point of view. And knowing that relationship between knowledge has to apply to all domains. We can't just create a app, right, for language. If you want to be a language learner and want to learn Cree, someone wants to make an app, the UI has to have cultural reflection in it. It has to reflect what is within that culture. How does it relate to the culture? The device that you're using, how does that relate to the culture? It's not just an app. There's a lot more to it than that. And that all came from my my master's thesis, where I wrote a computer program in processing to generate beaded portraits of my family. So it was just faster. I wanted to be able to see what it looked like if it was beaded. So I made this program that I could bead. So I actually beaded these portraits. This is my youngest son, Lucas. And what I've found when I was actually beading the work, that as I placed a bead, I'm literally programming in my head, counting, the beads along the row and going through the algorithm that I used to write it. And that algorithm doesn't reflect how I actually beaded it, right? So I get to the end of the row, I don't cut the thread off and tie it off into a knot and then go back to the beginning like a typewriter, right? Going left to right, left to right, left to right. I get to the end and I go down a row and I go back the opposite direction. So I rewrote the algorithm to reflect that practice. And this is one of those ways of understanding the system. It's sure it's going to be inefficient. It's not the way that the computer was designed to handle these things, but it's a better reflection of my practice and what I do. And that's culturally relevant to what I want the system to do. The only thing I thought that would be even better is if I could write that in using Cree syllabics. So the image here on the left is actually from the processing that I used. Actually, I think I used processing 2. So this is processing 3.5. You'll notice that when I used syllabics, they all come up with these little boxes. This is a problem with the font in processing. Um, and in 2022, the font that was used in Visual Studio, Microsoft Visual Studio, finally had a font that used Canadian syllabics from the standard. So the ISO standard that uses Canadian syllabics, they actually had a font that had the glyphs that I needed for the syllabics. I still have to write all my instructions in English, but at the very least, I can now represent variable names with those actual syllabics. Whereas on the left, this is the exact same text on the left and right. So all those little square boxes translate exactly to a glyph in each of those screens. So we are, it's slowly getting to a point where I can start to use my language, my heritage language. I still have to deal with this English instruction though. So I wrote my own programming language for Cree. It's called Ancestral Code or acimow, which means story. And it literally is just telling a story. This is an image of my UI. And what I did was I just looked at the basics of programming. One of the basics that I learned, variables, loops, and conditionals. With those 3 things, I could write, an application for just about anything, just understanding what a variable is, what a loop is, and what a conditional is. And I immediately ran into problems because when I asked an elder to translate, if I see, or if it is nighttime, then I see the moon, the translation I got back translates as at night I see the moon. There was no if and there was no then. So the language itself wasn't constructible to understand that condition. So I had to come up with a different way of expressing a conditional statement. And I borrowed from, there was a Hawaiian programming group that was translating, they were creating a transpiler for C# that converted Hawaiian, Olelo Hawaiian into C#. They had the same problem. They don't have this if conditional, if A equals B, then C type of language mechanism. And so what they came up with was the idea for river. So river branches, right? So they're using land-based ideas to represent the branching of a conditional statement. And I thought that worked well for my own language. Water is important, rivers are important. So culturally speaking, in Cree, if I use the word river, which is CP, I can branch that river into CP cis, right? Smaller rivers or creeks. That was the start of how I started to really program using story rather than using literal commands. And I had heard this comment from an Ojibwe elder named Duke Redbird, who talked about computer programming, talked about, he created this word called elder rhythms, which were just algorithmic expressions of elder knowledge. And I loved that so much. I have this in almost every presentation I give because I think that at the essence, it's exactly what it's doing, is it's saying how we write our code, if we do it culturally and with respect to the culture and in our language, we are changing the way we're approaching or changing the way we understand what an algorithm is and what coding is. And programming to me is also a healing process. And the reason I say that is you ask any elder, especially in, I would think among all of the uh, Native American tribal groups across North America, uh, about language, what does their language mean? They'll say their language is medicine, right? Our language is medicine. Using our language is about keeping our culture alive and keeping our stories alive, keeping our community knowledge alive. And because we do that, it's also ceremony. Using language is a ceremonial process. And so if I was to code that as an instruction, if language is ceremony, then computer programming has to be ceremony, and it also has to be medicine, right? So the act of computer programming is actually a medicinal act of ceremony that is an indigenous person. Um, and some people refer or might associate that to something like Zen. Like if you're really good, if you're a programmer, you've been in those moments where 3, 4, 5 hours, 10 hours can go by. You don't even realize it. You're so ingrained, so focused on what it is that you're doing, and it just becomes a meditation process. But I think I can use that as a way of healing trauma. If you're able to use your ancestral language, and you view ancestral language as ceremony and medicine, then just by relationship, programming is an active way of doing that and working through that. And I took that same thing, and this goes back to those other aspects of, if I'm not going to do it just with language, how am I going to work this into my UI? We have color theory. As a fine artist, I have an undergrad, my BFA, and had all kinds of color theory courses I had to take for that. My master's degree, I did color theory. But really, what is color theory, and what is it to who, right? And we have color theory based on optics. We have color theory based on uh, uh, artistic practice, aesthetics. So I created kind of my Cree version of color theory, and I created a medicine UI, which just takes color samples from our 4 medicines, which are tobacco, sage, sweetgrass, and cedar. And I color sampled those. I actually picked them, scanned them into my computer on the computer bed or scanner bed, used Photoshop to color sample them, created these gradients, and came up with a UI color set that I can use for my integrated development environment. So when I'm coding, I now use a color palette that uses these tones for programming. And then I also associated each one of those color decisions as to what it represents, because they are further related to those. So for example, tobacco, the dark tobacco color is for my comments. The dark sweetgrass, which is purple. So when sweetgrass is healthy and ready to pick, the roots are very, very purple. So you get this nice color purple. I use those for variables, right? And I have, longer explanations as to what each of these mean, understanding, because it's not based on the medicine wheel where we would typically have, red, yellow, white, and black, or green or blue. Red, white, and yellow are fairly standard, but there's no standard medicine wheel either. Every community has its own version of medicine wheel and their own colors and what directions those colors represent. For me, this was a better way of understanding color theory from my Cree perspective, is actually using the medicines as the inspiration for those colors. And that finally leads me to my prototype designs for my, now that I have looked at the language from the software perspective, how do I get the language into the system? Syllabics in Cree are known as spirit markers. And so they are representations of spirit. I started with the first version, which was just based on the basic 1U computer key square, and I liked it, but there was a lot of dead space. And I had a dream, like an elder vision. I had a vision where an elder came to me and said, you can take that middle ring and instead of using the 3/4 height keys, just make them square, but try to, close up some of that distance, that gap. between them and make them sit side by side, so they're a little bit more representative of a keyboard. And when I did that, I ended up with this metal version here, and realized that the orientation of this design, which I actually don't have it on here, is comes from the Cree star chart, how the syllabics are taught. There's multiple ways of teaching, but we have a device called the syllabic star chart, and it arranges our syllabics in these 8 directions. You'll notice in the middle, this in the middle image, there's a mi, an mi, me, ma, and mo in the 4 corners. And then the vowels, which are A on the left, I at the top, O on the right, and E on the bottom, are triangles. So there's a single syllabic that's rotated or reflected to one of the 4 directions, whether it's diagonal directions or the up and down, left, right directions, horizontal, vertical directions. So there's only one syllabic, but it's rotated or it's reflected depending on that direction to give you a different vowel sound. So they all represent a consonant vowel pair. So this arrangement is usually taught when you're first learning syllabics. Some people use it and some people don't. From this version 2, I still noticed there was a lot of empty space, and so long as the syllabics in them over, so I could fit, the syllabics into those diagonal positions, and that's what's left with the version 3 on the right. So now it's a circle. If you compare it to the very first version, it's very square, right? We have these 8 directions, very diagonal, very horizontal and vertical. And now I'm using almost the exact same relationship, exact same arrangement. There's diagonals and there's verticals and horizontals, but they're arranged in a way that is much more culturally reflective of how I integrate or interact with my language. And once I had that layout, I needed keys because those keys don't exist. And when I was building my keys in Autodesk, I noticed that these vertical seams that I had created 12 seams. There's a bunch of them aren't necessarily needed, but the yellow verticals there that bisect each of the faces. We have something in Cree. We have 13 poles in our pole teachings when we raise a TP. There's 13 teachings that attach to each one of those poles. Some cultures or communities use 15. Some use, I think, 12. The smallest I've seen is 7. But there's numbers, and 13 was big in ours, and so I needed a way to. I thought if only there was a way to represent one more pole, and I did. So I ended up trisecting the back face of the key. So even though these seams are not visible when it's 3D printed, they're there. And I thought this was a great way of, if the language, the spiritual marker sits on top of this structure, it's upheld by the 13 teachings of the TP. So the language is therefore supported by that community understanding. So that's what went into that key design. And then I did the same thing for the circuit board. So the circuit board, when we enter a lodge, you enter a TP for ceremony, you circumnavigate the floor space in a clockwise manner. That's how it is in my community. Other communities will walk counterclockwise. And there was an elder that once told me, the reason we do this is that if we all walked in the same direction, we would never meet anybody. And so by walking in these opposing directions, we have a chance to meet and greet and acknowledge and respect each other's space and culture, and doing it in the same space. And so I wanted to reflect that with my circuitry. I didn't want to make these linear squared off circuits. I wanted my circuits to be round, right? And so the circular traces on that circuit board are round. They're not, we're talking nanoseconds in terms of response time. So, yes, again, theoretically, it's not as efficient as it could be, but it is a far better representation of culturally how we do this. And the circuit, the microprocessor that I will tell you exists on the east here, even though that's the left, this is that example of geolocation. So in Cree culture, the elder that begins ceremony, they sit at the north end of the tent or lodge, and they face south. So if you imagine this circuit board was the footprint of a lodge, and you sit yourself at the bottom, not the top, but at the bottom, and face south because you're facing forward. This is how we relate to it in a Western context. Whatever direction, if you're facing forward, then you're facing north. And so here, if you sat down and you faced forward or towards the top of the page, understanding that that top of the page or the top of the circuit board in this case is south, that would mean that the east is the circuitry that is on the left, not on the right. When I understood that I had to redraw this because I originally had my microprocessor on the east, which I thought was the right side, and it is not. It's the left side, and that's the reason why. And that microprocessor being on the east is important because in Cree culture, the gateway to all knowledge is the sun's direction. So the sun rises in the east, and then that's the gateway to knowledge. And therefore, if your USB cable is what's connecting you to your computer, and that's the gateway to knowledge, it's how you get onto the internet. Then that microprocessor has to be placed to the east, so that it represents that transmission of knowledge that we see as coming from the easterly direction. Here's a couple examples of my finished keyboards once they were 3D printed and manufactured. And I'll wrap it up with just an idea behind, Indigenous computing and unveiling that knowledge that inherently, I think, is Indigenous in terms of computing. If you were to break down that computer into structures like I did with my programming language, you don't think of variables or loops. So loops, for example, are winters in my programming language. So you might write a program that says for 50 winters, ride your canoe, which is a variable container, down the river, and that river will branch. So when the river has a 5, go this way, and if a river has 10, go this way. And I'm going to do that through 50 winters, right? So the language itself is very storytelling like. It has a better understanding of what culturally what is relevant. And that is also applied to the way I develop the circuit board, the keys to my keyboard, the layout, the overall layout of my keyboard. So from the hardware to that software, and then just the general understanding of Indigenous relationships to the world and how our worldview is taken, how we can apply those to our computational theory and the overall framework of computing. And with that, I say aye hi, Kiranas Komitin. Very grateful to have presented this, and I think I'm pretty close to time, so thank you.